Evening and welcome to this week's edition of Roundtable Talk. As you may have heard during the week, the La Soufrière volcano has gone into a period of quietude. With that, though, has come the issue of Lahars, which we now understand from the professionals will become a real part of our reality here in St. Vincent and the Grenadines. To talk about the scientific impacts of that as well as the environmental impacts, we have with us today on Roundtable Talk volcanologist and the lead scientist on the ground currently, Roderick Stewart. We also have Professor Richie Robertson from the UWI Seismic Research Center. He has gone back to Trinidad after his stint here to return shortly, I think. And we also have our environmental specialist who is in the studio with me in Dr. Reynold Murray. Welcome, gentlemen. Welcome to the program. I'm going to first start by asking Rod to give us an update, the current situation in respect of La Soufrière as of 6 o'clock. So you're having the very latest. Rod?
Okay, thank you very much and good evening, everyone. And as you said, the volcano has gone into a state of quiet. Ever since the last explosion on April the 22nd, we've really had virtually no seismic activity. It cut off, which is a good sign. It indicates that there's no stresses building up beneath the volcano. But we do have some high gas measurements that we've made recently, so that the volcano is still active and still has the potential to explode. But it does seem to have come out of that incredibly active phase it had between April the 9th and April the 22nd, when we had more than 30 explosions. So it is quiet, but we still have to be very careful, and we still have to be very strict on visiting the red zone, because things could happen very quickly.
Okay, so you mentioned that there's still a high level of gas measurements. How high are these levels, and what are the implications of these high levels?
We've been making semi-regular measurements of the SO2 gas using a Coast Guard boat traversing underneath the plume. And the latest one we did on Monday was measured at over 1,000 tons of SO2 per day. Now that number doesn't mean anything because you need context, but that number is not what you'd get from a volcano that had gone totally quiet. It needs to be down around the 100 level. And so if we look at all our measurements over the past few weeks, I think we've had 3 that have been above 1,000 and the others have been lower. So it shows that the volcano is actively degassing. Gas is coming out of the magma. But because we're not having any earthquakes at the same time, it seems to be degassing easily. When it degasses, it often builds up pressure and causes earthquakes. That's not happening here. So this suggests that we've got an open vent, and that is probably a good thing because pressure doesn't build up. But we really need to get a look at the crater to see what's happening there, whether there is an open vent or whether it's trying to build a dome. That will really help us solve the question of why is the gas high at times and why are we having no earthquakes. I don't know if Richie wants to add to that because he knows more about gas than I do.
I think, Roddy, you covered it quite well. It clearly means that there is magma, gas-rich magma, close to the surface and giving off this particular gas, which comes out when magma is close to the surface. The one thing I'd like to say, though, so that people are not confused, the gas that's coming out that we're measuring is in the plume, is in this gas plume that is going out to sea. It doesn't mean that this gas is on the ground and in areas that are occupied. We are measuring it from a plume that's high up in the sky and we're detecting it. It might be that around the volcano and in the valleys leading in that same area where the gas plume is, there might be some gas hugging the ground. But it doesn't mean that the gas concentration in and around the Soufrière or in areas that are occupied, orange areas, are so high that people need to be concerned. So it's not a health issue. It's more a volcano monitoring issue. That's important that people understand.
Okay, so we have not been having earthquakes, we have not been having explosions, but we have been having Lahars.
Oh yeah.
Can you explain and tell us what exactly is a lahar, or what happens when lahars occur?
Okay. This is for me.
Any one of you.
I think so.
No, I'll
I can
start.
fit it after.
But a lahar, or it's sometimes called a mud flow. Basically, we now have lots of thick deposits of ash and pyroclastic flows on the volcano, and they're thicker the higher you get up on the volcano. And all the trees have been destroyed, all the vegetation, so there's nothing holding this together. So anytime it rains, the rain cuts gullies into these deposits, but it also picks up the material. It picks up the ash, and because it's got a lot of bulk to it and a lot of volume, it then starts to pick up boulders and trees, and they've been known to pick up people's cars if they get in the way. So it's this intense, thick, muddy flow that comes down the side of the volcano when there's heavy rainfall. And maybe not even heavy rainfall, it may be localized rainfall up there. And it basically destroys everything it comes across. I mean, it comes down valleys, so you know where they're going to go, but it cuts new channels, it clogs irrigation, it undercuts the banks, it brings a lot of stuff out to sea. And the videos that we've seen and that you're showing now just show some of the fantastic power of these lahars. My colleagues who were in the Walibu the other day, they said that there were boulders that were 5 meters across, that's 15, 16 feet across, that were rolling down in the lahar. The lahar was bringing down massive boulders. So this is something that you have, incredibly destructive. And the other thing is that they can happen quite quickly. They said when they were around the Walibu, there was a man walking in the riverbed because there was no water there. And this was only about 4 or 5 minutes before the lahar started coming down. So these may arrive with very little warning. So it's very important that people learn about lahar hazards and how to live with them if you're in an area that is subject to lahars.
Are there different kinds of lahars?
I'm sure lahar experts could tell you different types, and I've heard them argue because if it's not got material, they say, oh, it's a dilute mud flow, or it's a flood or something like that. I mean, at the moment we tend to lump them together. But one thing we have seen is we've actually seen what's called a hot lahar. So a normal lahar is what we call a cold lahar. It's just water that's coming down. A hot lahar is when the rain has got into some of the material in the volcano that is still really hot, and it actually heats up the water. And so again in the Walibu, you can actually see steam rising from the water that was coming down in the lahar, which is pretty impressive. We don't know what the exact temperature was. It might only be, 50 degrees C or so, but it could also be hotter than that. I think there have been cases around the world where the water is almost boiling when it's come down in a lahar. So that's maybe a distinction between a couple of types, but otherwise it's just widespread flooding and lahars.
Okay. When we come back, I want to talk a little bit about the dangers of lahars, and also to do a comparison with lahars in Montserrat, the Montserrat experience, and the Vincentian experience. We'll be back in just a moment. Welcome back. Before we get into talking about some of the dangers of Lahars, we have some comments. Someone is saying that's very good. None of the disturbing confusion that's been scaring the people. Non-toxic gases we can tolerate. Just saying. And somebody's asking whether or not the data collected from all of these events will be made available to the Vincentian public. Professor?
I'm not sure what data they're speaking of,
I don't know
but
the gas measurements
yeah.
and what have
Well,
you.
yeah. I mean, the data is hopefully following on from this eruption. There will be a long-term observatory at the in St. Vincent that will be one of the repositories for some of the data that comes out of this eruption. So it's just a matter of if people wish the data, it will be available. It's not that we're going to store it somewhere particular, because then you have to deal with storage issues, but more than likely be available either through the observatory locally or directly through seismic and their mechanism for accessing it. In addition to which, it will be written up in reports, in publications. You might have conferences that come out that would have all that data that has been worked and produced. The results will come out of that. So in a sense, it's going to be available in various forms and formats.
Okay. So someone wants to know whether or not the Montserrat experience and the St. Vincent experience are one and the same. Adding that Montserrat is now virtually a wasteland. I'm not too sure about that, but is the experience one and the same?
Maybe two and the same, although I'm not sure if that's a phrase. Yeah, parts of Montserrat are still a wasteland, although vegetation is coming back. But the big problem in Montserrat is that the capital, Plymouth, was basically on a pyroclastic fan from the volcano, and therefore basically got covered in pyroclastic flows. So the capital was lost during the eruption. Here in St. Vincent, we're lucky that the capital is as far as you could be from the volcano, to be honest, which is a good place to be. And we don't have so much of a population. So Montserrat has really suffered because the people had to move from the south of the island, which was populated, to the north, which was a lot less populated before the eruption. Here, long term, now we've had people have to move in shelters, but long term, you've not lost a lot of the infrastructure because there wasn't that much near the volcano. In terms of the Lahars, it is very interesting. I mean, Montserrat has been living with Lahars for a long time, and they're a part of life, and they don't get in the way of things because we're used to them. But that's because in Montserrat we've got a well-established pattern of Lahars. They've now sort of got their own channels, and we know that the Bellum Valley is one of the first places to get big Lahars, and then Plymouth itself. So the government can actually position equipment near the Bellum or take it into Plymouth and clear out these Lahars very quickly. For instance, the Bellum Valley, there was a bridge, but it's now actually been covered by Lahars. It is a major crossing, but it gets cut every time and there's big channels in it. But it can be restored maybe within half a day because the bulldozers are there so quickly, and that's very good. The problem we've got, I think, here in St. Vincent is that it's a new system. The Lahars are finding their way around this volcano. So we cannot predict as easily or forecast where the Lahars are going to be. They're going to be in the major drainage channels. I mean, that's obvious, but it will take a little while, I think, to establish a pattern of where the real damaging Lahars are. But I think the Montserrat experience is that you can live with Lahars, and you just need to be knowledgeable about them and prepared for what they can do.
Okay.
Could I add something to that?
Sure, you can.
Yeah, so Rod is quite correct. In Montserrat, most of the damage that's caused by Lahars it has a dominant river valley that drains the Soufrière hills through which Lahars pass. In the case of St. Vincent, there's a lot more options for valleys. There's a lot more valleys that radiate from the volcano. But there are established valleys. So we would expect that one of the dominant places will in fact be Rabaka, as one of the dominant valleys. Another dominant one would be Wallabu. And then all of the valleys that go north of Rabaka, so you're talking about the Waribishi, the Cayo River, Fancy River, all of those rivers that exist that are often dry you would expect that they could have Lahar activity.
Oh,
If you go all the way north, you would expect Lahar activity to develop in them. So I think the key thing is that while you don't know which ones will be, as Rod said, the critical ones, the ones that are going to be reactivated all of the time, I think to err in the way of caution, it would be to make sure that you don't develop any major structures in any of the river valleys that drain from the volcano, any of them, full stop.
yeah.
And then you have to look at how do you organize where your population live, and also how do you organize where you put the assets, like Rod spoke about. The critical ones that if something happens, you can clear the roadways and not have the villages cut off. Otherwise, what we would expect going forward is that when there's a rainy season, or even when there's sometimes no rain and not very much rain down in the valley, but up in the mountain there's rain, we'd expect that villages such as Ovia would be cut off from the south, from Georgetown, for example, because of Rabica. And then Orange Hill would be cut off from Georgetown, and then Orange Hill might be cut off from Sandy Bay because of Orabichi. And then Sandy Bay might be cut off from Ovia because of the river that passes through Sandy Bay. So that kind of thing would be expected even now. So therefore, even though you don't know which one will be most affected, I think you know enough about the river systems to know that, make sure you stay away from them. And secondly, there are some places that are going to be more critical than others in terms of getting people in and out. And thirdly, I think people just have to develop ways of surviving and living when you get cut off, essentially. So you have to build resilience in the communities themselves for the fact that they may be cut off more often than they're accustomed to. I mean, if you think of it, we've always lived with the Rabica coming down from time to time. The fact is that now, while we have been accustomed to the Rabica coming down from time to time in the rainy season, because of the amount of material that has been dumped on the volcano, it means that kind of thing is going to happen more often, and it's not only going to happen in Rabica, it's going to happen in all the valleys. So, I think we've said that you need to think carefully of what you're going to do north of the Rabica in terms of where people go and where you develop, because now, for the foreseeable future, you have this Lahar activity to deal with. And we've seen how disruptive they are, so you can't ignore them.
It's a perfect segue really into bringing in Dr. Murray. But before we do that, somebody's asking approximately how long do PDCs and hot Lahars remain hot? And somebody else wanted to know if it's true that gold particles were found in the ash. So before I bring in Dr. Murray, we could probably respond to those two questions.
And let Rod respond to the gold. I'll do the PDCs, Rod. Right? Right.
Okay.
So I'll leave the gold for the last, but that one is more interesting for
me.
It depends on how much rain falls. It depends on how thick it is. I would estimate that up until sometime in the foreseeable months, until you have at least 1 or 2 rainy seasons, probably next year sometime, you might have some areas that might be still hot, at least up in the valley. Depends on how thick they are. We haven't really investigated to see how thick they are, but it can continue being hot for several months after. That's the bottom line. But it really depends on how much reworking has happened, how thick they are, how much rain has fallen them, and that kind of thing. We haven't finished mapping them yet. That's something that's going on now. Rod, the goal to you, man.
Okay, thank you very much. Yeah, we saw this story. It's based, I think, on some measurements that were made by the UN people that were here, who actually brought some analysis equipment with them to try and analyze the ash. And in a couple of their samples, they found basically trace amounts of gold. And the values of this, I think, were 5 or 6 parts per billion. So it is very, very small. And there are traces of gold everywhere. There are traces of gold in seawater. I think the average concentration of gold in the Earth's crust is around 5 parts per billion. So the ash here is no different from any rock. And so although there are maybe traces, and their analysis is, because it's using portable equipment, it's not very accurate. There may be traces of gold, but it's certainly not in commercial quantities. I think the only way you could make money out of this gold is to propagate the rumor and then establish a store selling gold pans and gold sluices. That's the person that will make money out of any gold rush, not actually looking for the gold.
So there's not going to be any gold rush around here.
No,
there's no gold in them Lahar hills.
Dr. Maury, let's talk a bit about the environmental impacts of Lahars and how best we can manage them as we move into this new reality.
Well, in terms of environment, when we look at the impact, we're expecting distortions in the river valleys. When we measure impact, we always want to see the sensitivity of the receiving environment. We know what the hazard is, but we're not sure where the receiving environment would be at. By that I mean, is it going to end up in the sea, all of it, or is it going to be in the river courses? Is it going to be on farmlands? Is it going to end up in communities? If the river stream got blocked, for example, and all of it runs into a community, then that's a different impact from it flows down in the river stream and goes to the sea. If it flows down the river stream and gets blocked somewhere and just forms a bulk there as opposed to going out into the ocean, a different impact. So it depends on where the sediment from the Lahar ends up and the sensitivity of that area. Particularly, the coastline will be important for fisheries. Okay, so we can have disruption to our fisheries resource. You can also have, in our streams, I mean, it's interesting to note that most of our crayfish that we know them as are in the high elevations. Our low coasts have been fished out so badly. So most of the crayfish, if you really want to catch, you have to go high up in the river valleys. But those are the areas that are now being impacted by these lahars. Yeah. Those are the valleys that's going to catch a lot of this ash. So we are now talking about reduction in our crayfish and river fish, river life. So all the river cooking, etc., is going to be impacted, right? You're also talking about the whole idea of the water quality in these areas. How long is this going to be on? We know our waters in St. Vincent are surface water in most cases. So will this impact any of our catchment areas? If it affects our catchment areas, can we then expect to have disturbance in our water supply, disruptions in our supply because the streams are blocked or whatever? It puts more burden on the Central Water and Sewage Authority to maintain the water quality and the constant flow when these lahars come down. So what I'm saying in general then is wherever it ends up is where the impact is going to be. Agricultural lands, are we going to destroy our farm? Let's say if a guy has a farm growing whatever, and these lahars come down, all his sediments come, it covers everything, so he loses his crop. If it comes down the stream, we have more damage to whatever fish life or crayfish social life is disrupted. If it comes into the community, it can actually destroy houses, changing the way of life for people. So one of the things we have to do going forward is to become a little more adaptable, a little more versatile. We have to learn what it is we're dealing with and how to deal with it. You know, we run into some things that we are not accustomed to and we get a little uncomfortable, but it doesn't take much to really adjust because we are dynamic people.
Okay. Good place to end. When we come back, there's a question. I think all three of you can respond. Do PDCs and lahars generally create permanent land, or are they generally temporary and largely destroyed as rain falls and water runs through the valleys over time? Kind of like what we're beginning to see now at Wallalaboo. So, gentlemen, think about that, and we'll talk some more about that when we come back after this break. Welcome back. And just before we took that break, we were talking or trying to respond to a question with regard to whether these lahars do in fact create new land, something to that effect. Doc?
Well, creating new land is a strange kind of expression in the sense that if you're moving ash or mud down a hill to settle it into a form that it can become permanent settlement is really a long way off. If it comes down the riverbed, then it's not going to settle in the riverbed if the river keeps flowing, so it's going to end up in the sea, so that's not a permanent. In the community, are we going to allow it to remain in the community the way it is so it can be compacted? That's not a question for us. So permanent land in that case, I don't see that happening with the lahars. If it's an area where you had pyroclastic floor or material that hardens and becomes solid land, deposits on top of that, then over time I could see that becoming some kind of permanent expansion, but not in the form of it is. And we constantly trying to move it, clearing it each time it comes or it gets in our way and we're not adapted to living with it. I didn't see that.
All right. Somebody is asking the massive amount of water the volcano spewed out. Where did the water come from? And do volcanoes have a direct vent to underground water?
Richie, you can answer that.
Yeah, no, that's a good one. In fact, one of the things that is very interesting about this volcano is that it seems to have a lot of water trapped in it. It's probably not surprising because it's a classic, what we call stratovolcano. So it's made up of layers of hard lava, hard rock, and loose material. And it's not surprising that when rain falls, it collects in the loose material essentially and becomes groundwater, and it gets ponded by the hard lava that's, I say, either above or below it. So therefore, in the layers of the volcano, say, because of all the rain that falls there, there's water that gets trapped as what we call artesian water. And therefore, when hot material comes down and sometimes sort of excavate that, it then gets remobilized. One of the interesting results of this eruption, one of the interesting products that you had, is these kinds of lahars, which almost seem to be a bit of a slurry. You asked earlier on about classification of lahars. One of the things in which people classify them is in terms of how much material they have in it, how concentrated they are. And it seems that some of the pyroclastic flows, when they came down, they somehow remobilized a little bit of water that then got moving as a mud flow or lahar that took some of the pyroclastic flow with it, and it didn't really move very fast. And what it did is that it deposited material rather than eroded material, which is what the lahars that you see now that has a lot of water in it. And they are more erosional and they destroy land, while the ones that came before sort of put material into the valley. So there are different things that indicate to us that this volcano trapped a lot of water in it, and mainly because of the rainfall, and maybe is one thing to look into in terms of underground water supplies. You possibly have lots of supplies there, lots of springs that around the volcano, as most people know. That is where this underground water is coming to the surface.
Yeah, because the volcano used to have a crater lake all those months ago, and that's an indication that the volcano itself is sort of saturated with water, isn't it?
Yes.
Okay. Somebody's saying PDC is an abbreviation that not everyone will be aware of. Please, can you use the full terminology?
Right.
On occasion.
Okay, so PDC means pyroclastic density currents, and is a general term that refers to all kinds of rapidly moving hot material that usually moves down the mountainside as a mass or very destructive flow that follows the valleys and spread out, and it ranges from sort of classic pyroclastic density currents, pyroclastic flows, but it also includes things like surges, which are much more fine-grained and more dilute. So PDC is a term of pyroclastic density current, encompasses the flows as well as the surges and other variations in between. I'm sorry about that. We try to use pyroclastic density current going forward. To use.
Yeah, as scientists, we're encouraged to call them PDCs, but personally, I usually slip into calling them pyroclastic flows.
Yeah.
Okay. So another question. Some have been asking, what is the rationale behind lowering the alert level to orange? What factors contributed to such a recommendation being made?
Well, I mean, the main factor is that the volcano has been quiet since the 22nd. And so even if there is a restart, as the scientific team, we are confident that there will be precursors to that restart. And even if there's not precursors, it will only affect the red zone. It really will not affect the orange zone. And if you look at the different alert levels, that really fits what was described as orange alert. The other thing that I think is important, you don't want to be hanging around in a higher level. It causes frustrations, it causes problems, you get lots of questions, and it makes it difficult to actually have another evacuation if activity starts up again. So by coming down to orange, if you then, something happens and it goes back up to red, that's a really strong message that goes to people saying, again, we have to do things. But the recommendation to go to orange is based on an awful lot of discussion, consultation about the different monitoring techniques, different data we've got, and the current state of the volcano. And it really does reflect the status that we are in at the moment.
Yeah, I'd just like to add that in a general sense, what we try to do when we monitor volcanoes and what we do in this is that we have a mechanism by which we could respond as scientists, also indicate to the authorities and to the public what we think is happening to the volcano. And the alert level is just a mechanism by which we say, in red, it says that it's erupting, it's explosively erupting, it's doing a lot of nasty things. Once it stops doing that, then we have to decide what is the chances of it's going to stay in that state. Once it stops doing that, then you have to lower it back down because, as Rod said, You can't keep in this heightened state, because if you're in red, it means that it's supposed to be explosively erupting. If it's no longer doing that, then you naturally have to move down, because you might be recovered to move up. If you stay in red when you're not erupting, what happens when it actually starts erupting? You don't have anywhere else to go. So you have to have a mechanism like that where you go up and down if necessary. And once you have a monitoring system in place, once you have scientists monitoring, the idea is that the system works, as I think it has done, in terms of telegraphing to the public how they should respond as activity as we perceive it is seen. So currently, there is, as Rod said, there is very little activity happening. It's certainly not exploding, not very much seismicity, and mainly what you have is gas, and if the gas tells us as there's fresh magma at the surface. Given all of that, we think, in our estimation, that it really doesn't make it necessary for us to stay at this higher level and for us to go down, with the intention that if it does move to a different state, we can move up. And because of the systems in place, the public and the authorities and the government could respond and make sure people are not in harm's way if it changes, if the volcano changes. So that's a system that we have to manage how we need to respond given what the volcano is doing. And it's necessary, otherwise it will be difficult to respond when you need to.
Okay. Couple of questions before we take the next break. Someone wants to know, can these flows go on for a long period of time? Someone else is asking whether there is lava inside of the volcano that needs to come out. And someone else wants to know if there's an approximate time frame for the people who have had to evacuate to be able to return home. And is there any way to identify if it will be this year? And somebody else wants to know, is it safe, even after this eruption, for villages over the river to be rebuilt? And if yes, what can be done differently to protect the villagers? I think that last one we can take in our next break, but after our next break. But the first three questions, Professor?
Well, I think some of them is to Rod too. I think there are so many questions. I'm not sure if I missed half of them. You probably have to, Rod, you remember the questions? You could probably go with that.
No, I think
I'm trying to.
Can we have them one at a time?
Yeah, one at a time.
Lava,
I think, yeah.
and if the flows
yes,
are going to
yes,
go on for
okay,
a very long time.
Right, so lava, that's an easy one. The fact that you're degassing and you're having all that gas tells us that there's magma there. The magma is called lava. Once it comes to the surface, it comes out, it's called. So there is magma there, so therefore, in extension, there could be lava. If there's a dome, we call it lava. Essentially, lava is just a name that you call magma once it reaches the surface and starts solidifying. So the gas can tell you that there's magma there close to the surface. Whether or not it's a dome, we have to see in first. And the other thing is, can the,
How long
what's the other question?
Yeah, if these flows can go on for a long period of time.
Or the mud, the mud flows, I think we've said that before. I think Rod said it already, that the mud flows could go on for a long time. As long as there's material to move, the mud flows will go on whenever rain falls and whenever they get mobilized. And we think that there is a lot of material at the surface, all of the ash, a lot of the pyroclastic flows to be revoked. So I would, it's difficult to say how many years, but I would estimate at least this year, this rainy season, and the next rainy season, at the very least, I would think that you will have to deal with them. As Rod said, remember you were saying that in Montserrat, you have them going on for how many years now, Rod? Many years.
Oh, yeah.
So, they're still happening in Montserrat.
Yes.
Okay.
Okay. Was there another question?
Is it safe to say the volcano has now emptied its bowels and gone back to sleep?
No, it's not. The volcano's bowels are large and deep.
That's huge.
There is a lot of magma down there that's going to come out over thousands of years, if not longer. What it's done now is it's depressurized a little bit, so its stomach maybe has stopped rumbling a little bit, but there is still potential for things to happen. So yeah, I really can't say it's gone back to sleep. Certainly not this soon after the explosions. We need to wait a bit longer.
Okay, Professor Ritchie, before we take the next break, a quick question. The last eruption in '79 did not result in these kinds of lahars, right?
No, because you did have some lahar activity after, but think of it, in the Lahars eruption, you had pyroclastic flows going up into the upper parts of the Rabaca, only to in Laracai. Now we have pyroclastic flows in more areas, and you have a lot more ash. So you have a lot more material to come down as Lahars. So I don't think the Lahars was as big a problem as it will be now. It didn't go on for that long. It was probably mainly in Rabaca. I don't think a lot of the other valleys had a major problem with Lahars after.
Okay, when we come back, you'll explain to us why this is so. Back in just a moment. Welcome back. Before we took our final break there, Professor Ritchie, I was trying to find out what is the difference between the 1979 eruption and this current eruption, why Lahars did not become an important part of the reality as it seems to be now, that it's going to be a part of our everyday life. So why did this not happen in 1979?
I think the simple answer is that it seems that this volcano produced a lot more fragments of rock and pushed it all over the volcano, basically. There's a lot more material underground produced, especially in the earlier parts. Remember, all that ash came out in the beginning. You didn't have that excessive amount of ash, and therefore there's a lot more deposits underground to be remobilized. I think there was a Lahar problem, but it didn't extend for that long after 79.
Okay, someone is asking, when are you guys going to take a look at the crater and see what's going on so people can have a clear idea of what's going on? Rod?
As soon as we can. I mean, it's quite difficult to coordinate things because the volcano is almost always got cloud in it. And there's no helicopter available nearby for quick looks. And we're certainly not going to walk up there. That's far too dangerous at the moment. So we've tried on a few occasions to schedule a look from a fixed-wing aircraft. But the time it takes to sort this out and to get involved means that our last attempt, we only got a few glimpses into the crater. So we're going to have to keep trying that. But we do have satellite imagery from time to time that helps us. But again, this is dogged by the cloud cover. So I think we're just waiting for the like a perfect storm of things happening at the same time. A helicopter being here and a nice clear day and a volcanologist ready to go up straight away. We just have to keep trying every time we can, and one day we'll get it.
Yeah, I mean, just to add to that, series, it doesn't mean that. I think seeing into the crater is a fundamental thing. Visual observation is key, but it doesn't mean, as Rod has said, that we don't have a sort of a reasonable idea of what it looks like. I think one of the critical things we want to find out is whether or not you have any sort of dome formation. It doesn't, from the satellite images, it doesn't suggest there is, but we do have from the satellites and from previous times we've looked in, we do have a fair idea of what it looks like, but it's always necessary to get updated views, actually get views with a camera close by. So the detail that you could get is not currently available with the techniques that we use, but I think we have a fair idea. There's an open crater there that is taking up a lot of the what was the pre-existing crater. It's quite deep. There's lots of ash all over the place inside of it. And as I might have indicated before, the crater that is within the crater is actually, the ash is built up so much that the ash is actually almost resting on the side of the crater where you have the Larakai. So in the area where you have the Larakai, you could almost walk all the way around the crater. If people remember how it used to be, you used to have to go around and then go around in a rope. You can actually walk all the way around and almost get into the crater. Not into the deep part of it, but certainly inside the pre-existing crater that was there, which now has another crater, in sort of a hole in the middle. You won't be able to get into that easily because that's quite deep. So we have a reasonable idea of what it looks like, but you can't beat actually seeing through the eyes, taking some pictures with a camera on a clear day. And that's something that we constantly try to get. As anytime it's clear, I'm sure there'll be people that, and it's, the problem is that it's unsafe to do that now physically in terms of walking up. So we have to find remote ways of doing it. And as much as it's clear, we'll try. So we'll keep on trying to look in so that we can know for sure exactly what we think is happening.
Somebody's asking, where did those big boulders come from? Was it from the explosion of the volcano?
Well, we have big boulders in the volcano all the time. You have deposits from previous eruptions. You have deposits from this current one. So what the Lahars are doing, the videos, it actually cuts back into the side of pre-existing, the side of the valley. So it causes landslides. So material that was there millions of years before, thousands of years before, is now being remobilized. So the boulders are coming from essentially previous explosions, previous eruptions from the volcano, as well as this one. And you have, I make the point again, you have a lot of stuff came out of the last one. And what the Lahars do, they remobilize material that was there before. So all of that mixed in, you can get boulders of all kinds of size and make them very dangerous.
Okay. So someone was asking, there was mention of a spine, and does any recent satellite imagery suggest or show that spine still?
You know one for Rod?
No, I think it's for you because I've
okay, all right.
Following it.
All right. Well, I mean, the idea of there's from satellite imagery, there is a sort of a vertical mass of something that looks like solid rock in the crater, in one part of the crater. One of the reasons we really want to see is to verify exactly what that is. One of the thinking that it is not really a spine. It might be that the 1979 dome would have come out from a particular, part of the volcano. There's a left off from the 79 dome would be a mass of rock, sort of, if you think of geography, you have a neck. The volcano has a central part from which the magma came out, and that becomes solid. And if you erode away the stuff that is around that, you have this solid sort of inner core of the dome that probably remains. And we think it might be that, rather than necessarily being a spine that got pushed up. In other words, is a remnant of some pre-existing material that was there, with the rest of it being eroded away or blasted away. And we're now seeing the hard inner parts exposed. So, that's probably what it is. Currently, that's what we think. But we really need to be able to go up and look into it. I suspect that we need to get photographs. We probably eventually, once it gets safe enough, people would actually go up there and start mapping these things out and better understanding exactly what the configuration is of new material in the crater, because it has changed. And we need to understand what that change means.
Okay, somebody's asking a question, probably something that I probably would have, so that we can also have the environmental impact. Is it safe after the eruption for villages over the river to be rebuilt? And if yes, what can be done differently to protect these villages when the next eruption happens? I also want to go further and ask about the Lahars. Apart from heavy rainfall, what other indication can we get or would we get if they occur and when they occur?
I don't know. Rod, you want to take a poke at that? I could answer the guess, but
I can answer the last question. And the rainfall is the main thing to associate with Lahars. We do pick them up on our seismic monitoring systems, but it's almost it's impossible to use the seismic or anything else in terms of forecasting Lahars. And this is a lesson that's been learned all around the world. And Montserrat's the example. The way we guard against Lahars is we basically have a big signpost next to the river saying, if there is water running in this river, do not cross.
Yep.
And that's like the rule. On bigger volcanoes, you might have more warning time, but here it's only minutes between rain starting in a lahar and it appearing.
Yeah.
Now, that doesn't mean we're not going to try and do things. I mean, we've been talking to people about just monitoring the lahars. At the moment, we don't have enough seismic stations to say where the lahars are. We can just say vaguely they're on the windward side or they're on the leeward side. If we deploy more stations and get some of our broken ones working, we may then be able to use the seismics to pinpoint the exact valleys that the lahars are in. Not as a way of warning people, but more a way of identifying those valleys that have frequent lahars and that will then allow planning. But really, it's just rain plus valleys plus ash equals lahars.
I think that just points out, Teresa, the point what we're making, that really the best protection is just to simply stay out of the valley. So don't put any kind of major assets in it, because of the fact that it is a case of St. Vincent, they're going to happen so fast that it's difficult to provide a warning. Your warning would essentially be you're either seeing or hearing the stuff coming towards you. So it means that you really, if there's any indication that something coming down the valley, you just simply have to get out of that valley. And secondly, you have to make sure that you don't have something in it, like a house, for example, or farmlands, for example, which would cause you to have to go there regularly and stay there and not focus on the fact that you could get knocked out by a lahar.
Thanks, Dr. Murray. How best do we manage this new environmental hazard we are going to be facing?
Okay, in step one, the area where you have a lot of ash, where you're inclined to have lahars frequently, it's not a good place to start to resettle or to rebuild or to even begin your agriculture. See, if you have a pile up of ash there that can move quickly, then you're at risk anyhow. So it's not wise to go back to that area immediately. Over time, when we get a little more comfortable, when a lot of it is moved by more rainfall, etc., you can begin to consider that. But in areas like in the orange zone, for example, even when we move back there, people must now become more aware of the environment, more respectful of nature itself. We sometimes want to dare nature. I'm going to go there because just denying everything that is reality, everything that makes common sense. So we have to learn to respect nature. The animals do. They know when to move out, but we don't. So the adaptation I'm talking about is people becoming more aware of what is around them and being able to respond to it, having the proper warning systems in place and the preparation to respond once you get the warning. Because we go into these, like people go out to sea and they don't have a radio or anything and the engine break down, you left out there. Same sort of stuff. If you're going to go back into the orange zone and you start building, you're not going to build in the river valleys or on the edge of the river, even if you lived there before. So you have to adjust your life. You have to now move from some of the places that you had before. And even where you build now, you need to be conscious of what are the potentials for accident to happen there and how you're going to protect yourself, how you're going to respond with short notice. Okay? So we have to have a new level of consciousness in the areas that we move to.
Perfect note on which to end this evening's edition of Roundtable Talk. Professor Richie Robertson, my schoolmate, always like to mention that after my school's classmate,
Of course.
classmate. Rod Stewart, thank you. And of course, Dr. Murray, thank you three. We have to come back to this discussion, and we certainly will. There's so much more that needs to be said. So we'll definitely come back another evening. Thank you again, and thanks for listening. Good evening.
Good evening.
Thanks.